Hello, so this is the solution to quiz 5. So for problem 1, the first thing I'm going to notice is that the parent function is the reciprocal function. That means f of x is equal to 1 over x. With that in mind, that tells me a is equal to -2, c is equal to 1, h is equal to 3, and k is equal to 1 as well, from where they're located inside of g of x. Then that tells me that x comma y will get mapped to x over 1 plus 3 and -2 times y plus 1. And I'm just going to simplify the x over 1 to be just x. And then we had 4 important properties for the parent function. That was the vertical asymptote, which was x equals 0. The horizontal asymptote, which was y equals 0. A point, 1, 1. And then the point, -1, -1. So x equals 0 just gets mapped to x equals 0 plus 3 using the x coordinate of our formula up above. So that means x equals 3 is our vertical asymptote. Then y equals 0 gets mapped to y equals -2 times 0 plus 1, again plugging into the y coordinate of our formula up above. So y is equal to 1. So we have a horizontal asymptote at y equals 1. Then 1, 1 gets mapped to 1 plus 3, -2 times 1 plus 1, which is 4, -1. So there's one of our points. And then -1, -1 gets mapped to what does that come out to be? 2, 3. And then because I know it has to approach the asymptote, I'm going to draw my curves like this and like this. So that's how you do this problem using the formula. The other way to have done this problem is to imagine where the points originally were. So originally 1, 1 was here, which according to h and k, I have to shift over 3 and up 1. So it would have ended up here. But then according to A and C, I don't stretch it horizontally, but I have to flip it because A is negative, so it'll get flipped to here, and then stretch it by 2. Stretching it by 2 brings me to that point. So that's one way to visualize where that point comes from. And now if we do the same thing with -1, -1, again, I'm going to shift it first, so over 3, up 1. Then we have to flip, so it goes here, and then stretch by 2, and that's how we get that point. And since stretching does not affect the asymptotes, to visualize how those move is those only get affected by h and k, and that's why they, the horizontal shifted up 1, the vertical shifted to the right 3. And that's how you go about doing this problem. Now I'm actually going to do number 2, 2 different ways. Again, I'm going to identify what the parent function is first, though. Which is f of x is equal to the cubed root of x. And then we don't know what our formula is, but I'm going to write it out right here. It's normally x over c plus h. And then a times y plus k. Now we did have 3 points for the cubed root function. The first point I'm going to examine is 0, 0. So 0, 0 would normally be here. That's getting mapped to the point -1, 0. Well, according to the formula, this gets mapped to 0 over c plus h and a times 0 plus k, which is h comma k. But I also know that that has to match up with the point -1, 0. And if I compare the x coordinates, this tells me that h equals -1 and k equals 0. So that's how we go about getting h and k. So now if I plug those values up into this formula, we get a -1 here, and that becomes 0, so it disappears. Now the next point I have is 1, 1. Where does that get mapped to? Well, that would be 1 over c minus 1, and then a times 1, which is just a. And 1, 1 is here. Now, I actually get to pick which point it goes to. I'm going to pick that this one moves all the way to this point because it has whole numbers. So that means this is also equal to the point -5, 4. Well, right there, when I compare my y values, that tells me a is equal to 4. But now when I compare my x values, I get 1 over c minus 1 is equal to -5. So I add 1, get -4, and then I can raise everything to the -1 power and get c equals -1/4. Well, now that I have a, c, h, and k, g of x is equal to 4 times the cubed root of -1/4 x plus 1, and then plus 0. And that's one way to get the answer here. Now, the second way to do this problem starts out the same way because we have no choice. 0, 0 has to get mapped to this middle point of this graph. So h is -1, k is 0. But I didn't have to choose that point up there for this second point. I could have chosen to map this to that point instead. So then that changes our calculations just a little bit. So let me delete these. Erase this. And we get that goes to -3/2, 2. So now a is equal to 2, and 1 minus c minus 1 is equal to -3/2. So if I add 1, 1 over c is equal to -1/2, and then raise everything to the -1 power, we get c equals -2. So we get a second equation where g of x is equal to 2 times the cubed root of -2x plus 1. And if you would graph both of these equations on Desmos, you will see they produce the same graph. So either of these answers would have been accepted. And those are the solutions to the quiz. Have a good day.